Okay, so I'm Wushi Goldring. I want to tell you about the definition of a group. So a large part of this course is going to be about groups. Let's see the definition. So let me give a formal definition and then let me explain a bit what it means. So a group is a set G together with two maps so one map is called multiplication. It goes from the product of G with itself back to G. And so we can call this map M, but we usually write it just as taking a pair G comma H and G times G and sending it to G dot H. So we write G dot H for M of GH. And in fact, very quickly we forget about the dot and we just write G followed by H for the product of G times H. So that's one map that we have. Second map that we have is inversion. This is a map from G to itself. Let's call it I for inversion. This sends an element G to, so I of G, and here the standard notation is G to the minus 1. And now these two maps are required to satisfy some axioms, so such that, so first of all, there exists an identity element E in G. So what does it mean that it is an identity element? It means that for all G and G, we have G times E is E times G is equal to G. And secondly, multiplication is associative. So this means that if you multiply more than two elements, it doesn't matter where you put the parentheses. So if I have G, H, and K, then I can put the parentheses either like this, multiply G times H, and then multiply that by K. Or I can put the parentheses like this, G times H times K. And those are the same. And this means that now also more generally, if you look at a string with more than three elements, doesn't matter where you put the parentheses. So from now on, when we work with groups, we usually don't write the parentheses, except to sometimes to explain what we're doing if we first want to look at this as an element and then multiply it by K, and so on. And finally, we need a relationship between the multiplication and the inversion. And this is given by that if we multiply G times G inverse, then we get the identity element. So this is true for all G and G. And here the associativity, this is for all G, H, K in G. Okay, so I gave you the formal definition of a group. Now I would like to briefly explain more concretely what it means and then to give two examples which will be two of the main examples discussed in this course. So what does it mean that we have this multiplication plus inversion maps on a set G? So what does it mean? Okay, so what it means is that we have G, we have a multiplication. So that means, for example, if we're given a set G and we want to check if it's a group. So let's say with a multiplication, and we are given that, we're given a set G with a multiplication, want to check if it is a group. Okay? So the first thing we should do is to check that G is closed under multiplication. So check G is closed under multiplication. What does this mean? This means that if we have two elements G and H in G, we need also their product G times H to be in G. We will see in a second, you might have situations where you can multiply any two elements of G, but you get something that lies in some bigger set. And okay, secondly, we need to check that G admits an identity. So that's just like the axiom that I had. We need an E in G such that E times G is G times E is G. And you will see this is usually the easiest axiom to check. The identity is usually something that some kind of identity function, or the number 1 or the number 0. It's usually quite obvious. And finally, we need to check that inverses exist in G. So for all G and G, we need to find an element G inverse which should satisfy that no matter which order we multiply them, we get the identity.